What I'd like to accomplish in our last, call it 5 weeks or so, is bringing in, it's going to be we're going to have to purposely have kind of a small implementation of something. This isn't going to solve all the world's problems. But I'd like to link in some other technologies. I'd like to link in a third-party database like a Firebase or something like that. So we, kind of have that experience of storing data in a server somewhere. So we have that experience. I'd also like to have, we have this Android app we're building, but, the idea here would be we'd have our app. Here, let me draw a picture here of kind of where I want to go with this. I've been clicking update for like a week, and so let's say no. Let's say I have not gotten it to, because I still have it cooking. It's still running this update. No, not yet. I mean, all these say update, right? Oh, do I have to accept? I must sign in. Okay, so we'll accept that. And then we'll click update there. This is really a poor design. Shouldn't they show you like some sort of progress instead of just like, oh, the depressed update button?
I think the update button does have a little progress bar that goes on. It does on.
Well, I've clicked accept. I'm not sure if they've accepted my acceptance.
There's a lot of models. Nothing for you. No feedback.
Yeah. Are we just supposed to trust Apple? Trust their nice little spinner thing here? That's your official answer. No. All right. Well, so anyways, what I want to have is you might be, all of us in here might have our Android app out, right? Okay, we're playing this game. And we're all connected into the same world, right? So somewhere in the middle, we have to have a server. Where when I first open the app, I authenticate with the server, you authenticate with the server, you authenticate with the server. So the server's keeping track of all of us in the world, all right? That way we can communicate with each other. So something we're building in the 450 class is a chat server. So we probably wouldn't go that far in here because we're going to have to just do light stuff, but go ahead.
Alternatively, peer-to-peer.
Well, right, but I'm not sure peer-to-peer works that great for chat. Peer-to-peer works great for like file sharing. Yeah. Where so BitTorrent is a peer-to-peer application. Yeah. So we'd really be looking at what's called a client-server model. So we'd have the server sitting in the middle, all the clients connect to the server, and then the server is kind of like the phone switchboard. If you think back to like the old, the way it used to actually work, but you've maybe seen it in some movies before, where somebody picks up the phone and says, get me Dr. Smith. And then the switchboard person, plugs a cable in here, and then the phone rings over in Dr. Smith's office because those two are connected by this wire, right? Well, so that would be kind of the job of that server where when I moved, where I typed something in my version of the app, it would notify the server, then the server would notify everybody else of that, now there's something has happened, a new person's in the room. That makes sense? All right. So then beyond that, we'd also want to have, our app kind of be living to an extent. So like as we start building our user interface here, we're going to have this idea where when you go into a room, you're going to see who's currently in the room. I think if we go back to our code here, we have this idea there's going to be potentially other players in the room. There's going to be some NPCs in the room, non-player characters. We're going to see some exits. There's going to be a description and a name. Well, when we first go into a room, maybe all I see in there is Charlie. Okay? And Maybe a minute later, Maddie walks into the room. Okay? Well, unless my screen refreshes somehow, I'm not going to be aware of that. Does that make sense? So then we have to think about, well, how often should my screen refresh? How does this ultimately work? Does my app, does it sit there and maybe every 5 seconds, does it check to see if there's been a change? And if there's been a change, then it updates the screen. Or whenever something updates the map, does the server push out to all the clients through maybe a second thread that something's changed, you need to update your screen? All right. So when Maddie goes into the room, I'm not immediately aware, but when she moved into the room, she notified the server that I've changed rooms. Then the server notifies everybody who is in the room she's moved into that they need to refresh their screen to see this change. Does that kind of make sense? So a couple different models we can use, but we're kind of building kind of a miniature client server model where this is indicative of a lot of different applications that you might write in the real world, even though it's a small version of it. Okay. So having said that, let's go ahead and let's try to get our base interface kind of going here so we can at least see what a room looks like, and then we'll worry about building in things to have people going in and out of rooms and then having more than one person playing our game at once, because that's really going to be the second level of this, right? Initially, it's going to be us traversing a cave just in this local thing. Then all of a sudden, you would like there to be multiple us's, where real people, 5, 10, 20 real people could be playing the game on their own device, but see other real people. I mean, every mobile application you mess with today is typically, or a high percentage of them, are multiplayer, right? You have other real people that you're playing against or something like that. And that's very much commonplace today. So we want to try to create, some scenarios where we're the ones implementing that piece. Okay. So last time, I think we were talking about hashes, and we were going to use a hash table. So we mentioned that a hash is a one-way cipher. So depending on what size the hash is, if it's 256-bit hash, for example, you have an arbitrary size input that spits out a fixed size output. All right, so the idea here would be, since we're going to be using this for our exits, we're probably not going to have an issue because within an individual room, we are probably not going to have more than one exit name that maps to the same value. North, south, east, west, if we kind of say that's maybe not all the exit names you might have, but that's most of them, right? All those guys will hash into individual values. So we're not necessarily using the hash technology for any sort of real advantage other than this thing that historically has been called an associative array, more recently is called a dictionary, where I can say, give me bucket north. And bucket north would hand me the exit object that corresponds to the hash value north. So when I put in north, that hashes to some bucket in memory. That makes sense? So I'm using this more from a practical perspective than really needing hashes. That's just how this ends up working in Java. So we're going to go ahead and we're going to say we're going to create a new hash table. And this is going to be a hash table of a string and an exit. Okay. I'm just going to close that for right now. Okay. So now, when we first build a room, we'll build a room passing it the name and passing it the description. That's going to be the baseline. Then we'll start filling in those gaps. We will add players to the room. We will add NPCs to the room. We will add exits to the room. So let's go ahead and let's do our players first. So we'll say public void add player. This is going to take a player P, and we already created a object for our player, but a player doesn't have much going on for them yet, right? We've just given ourselves the base object so we could work with that. So we're going to, let's see, where am I at here? We're going to add a player to a room. And what does it mean to add a player to a room? Well, for right now, adding player to a room is going to mean that we're going to take our linked list of players and we're going to add this person to that linked list. So this dot players dot add that player. Now, let's pause for a second and let's think about from a player's perspective. Now, a player is probably going to have a name. A player is probably, you know, if we kind of think down the lines of a video game, they might have armor and weapons and blah, 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 all this other stuff. But at our very generic sense, where we're just traversing through a cave here, a player at the very least maybe has a name and maybe they know what room they're currently in. Right? Kind of makes sense? So let's go back to our player here. And we're going to say a player has a private string name and a player has a private room, current room. All right, and we'll go ahead and create our constructor for player. And this guy will take in a name. And we'll say this dot name is equal to the name that was passed in. And we'll say this dot current room is equal to null initially. Because when a player first comes into existence, they haven't actually been plopped into a room yet. Okay? So now we have to have the ability of, we need to give ourselves getters and setters for these couple of things. Probably don't need a setter for name. Probably not going to change a person's name, but a getter for name, and then a getter and setter for current room, since that's something that we might be modifying. Okay? So we'll go ahead and generate some stuff. I'll generate, let's just do a getter for name. And then we'll generate a getter and setter for current room. Can you think about how much worse that was when you used to have to just write those yourself? It's like good practice at first until it's just annoying, because it actually promoted bad programming. Because what people would do is they would say, oh, well, this is a kind of a headache, so let's just make everything public and I'll just directly change it. Some languages, before you relied on the IDE here, you would be able to create a variable that was what's called synthesized. So you would use a keyword, like Objective-C supports this. You would have a keyword in front of this called synthesize. And what it would automatically do is it would generate getters and setters for you. Which really wasn't, but they would be generic ones. So that's really not any better than just making it public and allowing people to get the value or change the value directly. But it is interesting how far IDEs have come. Even something so simple like this that we rely on now for just, you know, I had 3 getters and setters, we were able to write it in 2 seconds instead of having to spend 3 minutes. 3 minutes adds up. Okay, so there's our player. Now, when we set the room for our player, that's going to override this local variable. So we do need to kind of be aware in the future what that process might be like, and we'll come back and think about this in more detail when we actually have a player in room 1 and they take the exit to the east, and now we have to remove them from the current room and add them to the next room, because we're really keeping track of the players 2 ways, right? A player knows about themselves and knows what room they're currently in. A room knows what players is in that room. So when a room has a player leave, that room has to go through and remove that player from that room. And then when a player goes into a new room, that room adds that player to the room. That makes sense, the process? Because you don't want to have a situation where, you know, because this would be kind of creepy if, like, you're going through this dungeon and Charlie's in every room, right? He never was removed from the room. I mean, that would be scary, Charlie, right? Just Charlie there with the giant war hammer. All right, so we want to make sure we don't have, because that would be perfectly allowed in programming, right? We just have multiple pointers to the same single object. Who cares? I mean, Charlie could exist in 5 rooms at the same time. We want to make sure that as Charlie moves from room to room to room, we remove him from the room he was previously in. That shockingly retains its heat. It's hot tea, and I made this about an hour and a half ago. And now I have an 8th degree burn on my tongue. I just made it up. It's a thing. All right, so we'll go back to our room. So now when we add a player to the room, we'll also let that player know that they are now in a new room. So we'll say p.set current room to this. This is the room that the player is currently in. Make sense? All right, so we're kind of letting our game kind of organically grow here, right? Let's see if our update is done, because I'd really like to keep our... of course it's not. Shall I kill this and relaunch it? Or is this one of those things where like the university is like blocking Apple? That doesn't mean, oh, see, you cannot connect to the App Store. That might be it. So I have to accept again, so that acceptance isn't going through because it can't talk to the App Store. What kind of signal do I have on here? I have 1 bar. I'll have to try to do it. I'll do it later on. It's not the end of the world. All right, so when we add a player to a room, we add that player to the current room, and then we change that player's current room to the room we just added them to. Similarly, when a player leaves a room, okay, when a player leaves a room, we need to go through our players array and our players linked list and remove this player from that linked list. Now, under what circumstances? So I want to think about this resource that is our linked list of players. What are the different circumstances where that linked list might change? Because that's a resource we need to protect. We cannot have 2 different people modifying that resource at the same time. Because if I go to remove player 1 from my players, and I go to remove player 2 from my players, and we're modifying this linked list at the same time, you might end up breaking the list. This guy might find the guy you're trying to remove at bucket 3. This guy might find it also at bucket 3, depending on whether or not this guy's already finished and maybe this new player is the new bucket 3. Make sense? So you don't want to risk having, changing a linked list is going to be fast. But you do want to kind of control, almost like a bouncer at the door. You want to control who's allowed to come in, who's allowed to grab that resource, and things like that. And so at the very least, when we remove a player from a room, that is giving us access to this players array, and we want to, or players linked list, sorry. We want to control that. Now, I want to try something here. Private, don't think we could do this. Yeah, you have to associate it with a function. It's not allowed on it, because that would be nice. If I synchronized the actual resource, where no 2 things could access that resource at the same time, that would be a nice thing. Now, we also have to consider that for our client, our local client here, if we only have 1 player being involved, there will only ever be 1 person accessing this, calling our RemovePlayer function. So let's talk about making this function synchronized. When I make this function synchronized, I'm saying only 1 thing can call this function at the same time. Anybody else is going to have to wait some fraction of a fraction of a fraction of a second until this resource is loosened. In the 450 class, we're starting to talk about the details under the hood, how this works. And here we care more about that, oh, this is the thing, here's the fix. That makes sense? So by making this function synchronized, we say only one entity can call this function at a time. And they have to wait for the next guy. And somehow, magically, the synchronized keyword does that for us. Make sense? Now, under our traditional use of our applications, where we've always been the one user, of the app, you wouldn't really have this issue. Two people aren't going to call RemovePlayer at the same time anyway. But if we're kind of thinking ahead here, and we're starting to think that, oh, well, we're going to have this server that sits in the middle here. All the apps are going to connect to this server. Whenever, if Maddie moves to the room to the east, and I'm currently in that room to the east, and that needs to update, my application is going to get notified somehow, right? And I might have removed or added a player to a room on mine at the same time as I was maybe moving rooms. If I'm heading to the north at the same time as she's coming in from the east, this could be a problem, potentially. If you only have one or two players, I mean, the chances of it actually being, what we talk about in 450 as being something called a race condition is low, but it only costs us one little keyword here, right? There might be a little performance overhead with synchronized as well, so you don't want to just use it willy-nilly, but we're going to go ahead and say, that player thing, I'm going to put a little comment above this. We want to protect the player's resource. So 2 or more entities cannot access it at the same time. Something along those lines. So we're going to use that synchronized keyword to pull that off. Okay, so now when we're inside of RemovePlayer, we can confidently say, I'm allowed to search through the players array, players linked list, and look for the player that we're trying to remove and get him out of there. I can do that now and not worry about anybody else changing that resource at the same time. Okay, so we need to look at, let's actually look at the documentation instead of doing trial and error here. So I'm going to pop open documentation, java.sun. Java APIs. We'll do 9. Isn't this the thing I saw last time that the format changed? Let me go down to java.lang. Oh, wait, hold on. Is that the frames versus no frames? Ah, yeah. I'm guessing that the new trend is to move away from having frames in your web pages. That's why the default is away from that. But I'm used to looking at the documentation this way, so that must be the correct way. Where's my java.lang? I realize this is out of order now, but I expected to see something else. Well, it's definitely not in there. Am I in the wrong? I might be in the wrong documentation thing. Here. We'll just find linked list. Oh, that's interesting. So now we're actually, my knowledge has officially become dated. So in Java 9, they no longer have java.lang. It's now java.base. Kind of means the same thing, but this is the base Java language that's built in, that's generically there in every one of our files. We have that invisible import java. Well, I guess in this case, java.base. And then inside of that, we have a package java.util where our linked list lives. So we want to go and look at the various ways that we can remove something from a linked list. So we'll scroll down here. Here's our adds. Here's our gets, so we can return the first element without changing it. We can find out where something lives, return the index of the first occurrence of the specified element in the list, or -1, so we can certainly find the bucket in our linked list where a particular player lives. So notice this guy takes an object as a parameter, so it's going to be looking for the matching memory address. Notice that we have some of the functions were associated with stacks and queues in here. So peek is built into linked list because the stack data structure is built in terms of the generic linked list. So is pop, so is push. All right, remove retrieves and removes the head of this list. Remove at index removes the first occurrence of the specified element from the list if it is present. So this kind of seems like it's the one we want, right? Call remove, pass it the player we want to remove. Let it look through the linked list for us. Find that guy if it's there and remove it. It'll return a Boolean true if it happened and a false otherwise. Kind of look like the tool that we want. Splitterator. Man, that's fun to say. Creates a... That's like a good character name for like D&D or something like that. It's a Splitterator, the brave.
Barbarian.
Yeah, no, probably a mage that refuses to use magic.
I see.
Okay, so we'll use. I wanted to see what Splitterator does. Creates a late binding and fail fast Splitterator. You can't define something in terms of itself. Oh, the Splitterator interface. That must be something that can be split apart because it's an interface. What's the word of the day? Splitterator. Yeah. It's so you can split things apart that are not like we've used split for a string where you can split it on commas. Well, if you want to split a linked list of players, we might want to split it on some other characteristic that is an inner characteristic of player, an inner field of player. Still very fun. All right, so we're going to call remove with the Boolean. So when we remove a player, we're going to say, I'm actually going to throw an if around this right now. That way we'll be able to test it to make sure it's doing what we want it to do. So we're going to say if this dot players dot remove, and the player we're going to remove is player P. So if that returns true, all right, that means it was able to remove that player. Now we are presuming that the same player doesn't exist in the same room at the same time, more than once. Okay, so we're hopefully, especially since we're protecting RemovePlayer, presumably we would also protect AddPlayer, so that the same player cannot be added to the same room at the same time, or two people added to the same room at the same time. Now, we actually have a little bit of an issue here. So I've now synchronized both of these functions. The same AddPlayer cannot be called more than once at the exact instant. RemovePlayer cannot be called more than once at the exact same instant. But have I fully protected my underlying resource of players? Could somebody be adding to players at the same time as somebody's removing from players? Could somebody call this function and this function simultaneously? Yeah. Synchronize on a function just says you can't call this function more than once. But each of those guys could be called at the same time. Go ahead.
What if we then have a public parent function where you pass in the player, pass in a mode as add or remove?
Okay, we could do that, where you have all these functions, and when you call a function, you have to kind of give it a directive. All right. Might get a little, I don't know, annoying pretty quick to do that. Got a better solution? Because ultimately, what do we want to do? We want to protect the player's linked list. How can I lock down the player's linked list? Final means we can't change it. Yeah, I want to make sure that two people can't access it at the same time. Because now I've created this possibility, as unlikely as it might be. You know, the most number of players we're going to have in our game is maybe like 3. Okay, so this is not a likely occurrence, but we want to still consider it from a computer science perspective. I really want to protect that resource. So what if I did something like this? Synchronized private get players. This is going to be a linked list. And then this guy returned this dot players. Now I've given myself access to that resource on a one-off basis. But does this solve the problem either? If you have 3 people who all want this resource at the same time, fine, I'm only handing them the resource one at a time, but they're going to be able to get the resource at the same time, depending on what they're doing, right? Because I'm not doing any sort of blocking here. I'm saying, yeah, here it is. I'm not marking anything off as this isn't accessible or something like that. How could I? I could use a flag. So I can come up here and say like a private Boolean let's call this players is locked, something like that. And maybe this guy starts off as false. Can't have question marks in your variable names. So this guy starts off as false. It's not locked. So the very first thing we would say when we say get players is we would say while this dot is locked, we're going to sit there and spin. So this is a while loop that has no body, right? There's no logic I want to do there. I just want to sit there and say, are you locked? Are you locked? Are you locked? Are you locked? And then as soon as I can break out of this, then I'll go ahead and I'll now say this dot players is locked is equal to true. I'll lock it. Then I'll return it. But now I need to be able to unlock it. That creates another problem, doesn't it? See how the layers just keep coming, that, we have this one resource we're trying to protect. You put one hurdle in front of it, now you've created a new problem around that hurdle. Does his solution maybe work? This inconvenient thing? Well, it's a little bit inconvenient, but we could build it into the functions. So we could have something like this. Players perform action. And maybe this guy takes in a string action. And then maybe it also takes in maybe an array of objects for the type of action. It's going to, some actions might take one parameter. Other actions might take 3 parameters. So I can have this guy take in an object array called params and have this guy perform whatever this action is based on these parameters. So now we can say if action dot equals synchronize private if action dot equals, and let's say we'll call this guy AddPlayer, then we're presuming the only parameter inside of params would be a single player. Correct? So we'll go ahead and we'll say this dot players dot remove params at bucket 0. That's the player we want to remove. Else if action dot equals, I'm sorry, I have it in the wrong place, don't I? I'll just move it here in a second. If it's remove player, we'll remove the player. If we're adding the player, we'll say this dot players dot add params at bucket 0. Okay, now notice this guy's complaining because the linked list cannot be applied to a generic object because it's a linked list of players. So I'm going to say, you know what? I happen to know that bucket 0 will be a player. So let's cast it to a player. All right, because whoever called me must have known how to call this function. Therefore, they would have said, if they're adding player, they would have made sure they loaded into bucket 0 of params a player object. And then I'll go ahead and I'll take the player version of that player object and pass it to add. This is probably not required here, but it wouldn't hurt for us to say the player version of that either. We're going to remove the player version of this object. Make sense? If nothing else, it kind of shows us that we recognize that that's a player that's in there. All right. So now we have a synchronized tool here for performing an action as it relates to the player's resource. So now what we would do inside of AddPlayer, now we also need to change this guy here. So for adding a player, we'll say the player version. In fact, for simplicity's sake, why don't we do this? We'll say player temp is equal to the player version of params at bucket 0. Then we can say go ahead and add temp. And then we can also say temp.set current room to this. That make sense? And then what we would do down here for add player is we would say this dot players perform action. What action? Add player. And then we'll go ahead and give it an array containing P. Is it really not going to let me do... Oh, it's actually this. I can't create an array. It's very rude. So we'll call this guy an object array. Params is equal to that, and we'll pass it params. So I just built my single bucket array that has one element in it, and that's P. And then I go ahead and pass it there because it wouldn't let me put this in as an array literal, as some parameter to this. For some dumb, they didn't know what they were doing writing the language thing. All right, so now I don't need to make AddPlayer synchronized, right? Because the thing that AddPlayer calls is synchronized. That makes sense? Similarly, we don't need to make RemovePlayer synchronized. Instead, we'll go ahead and we'll say, well, I need to give myself my object array. Params is equal to also just a P. We'll say this dot players perform action, what action? Remove player. And then the params will be my params, like that. All right, so add player and remove player will internally call perform action the correct way for our players. And we're protecting the call to this function. Now, when we remove a player, we're going to try to remove the player. So we'll say if this dude returns a true, I'm actually going to go ahead and do that temp thing. So if when we try to remove from players the variable temp, if that worked, if we got a Boolean true out of it, that means that player temp has been removed from the room. Therefore, we'll say temp dot set current room to null. They're kind of in limbo right now, right? Because at this exact moment, that player has been removed from that room. They may not have been put into another room yet. Okay, they may not have been added to a room up here yet, but they have definitely been removed from this one. And we want to take advantage of us being synchronized right now to make sure that at any point in time, the current status of that player is accurate, even if it's only for some fraction of a second before they get plopped into another room. All right, that kind of makes sense what we're doing here? All right, so not that bad, but we have to worry about more stuff. The second we start thinking about bringing other things into our application, bringing multiple players into our application and having, more than one thing happening at the same time, all of a sudden our responsibility goes way up, doesn't it? Now, this is the type thing where had we not done this, it's entirely possible, maybe even probable, that we would have never had an issue. That our program could just run along nice and happy, never actually have two people try to change that player's array at the same time. So we might say this is a big waste of time. But it's for that, 1 in a million chance that it happens and you get this strange crash bug, right? Because you've broken your underlying linked list because two elements, or we get an exception. I think it's like an inconsistent data structure exception or something like that. Where it says, two guys have made modifications to this underlying linked data structure, and it's no longer linked the way you think it's linked. That type of thing. So kind of better to be safe than sorry, right? So then we would ask the question, why don't I always do this? Even in a situation where I don't necessarily have the possibility of having more than one thing access a resource at the same time, in case I expand the program at some point in the future, why should I just always synchronize my accessor functions like this and kind of wrap them in a perform action? What would be the downside of doing this all the time? Probably a lot slower. But in this case, it's worth it. And a lot slower from a computing perspective. We're probably not going to notice the difference, right? And even in, we think about video games and things like that, the networking components of video games are often they don't rely on speed as much as graphics does. Because you're not sending a whole lot of information. When you have one of these multiplayer games where a zillion people are all in the world at the same time, the amount of data that's actually being sent across isn't that much. So it's not a bandwidth issue, which then becomes kind of an interesting question when somebody, says like, oh, well, I need to have the, what they call the best internet or the fastest internet. They need to get the 300 megabit per second internet because they need to be able to play their World of Warcraft game. Okay, when 10 megabits per second would be just as good for World of Warcraft from the same provider because they're going to have the same latency, the same ping rate. So data will be able to travel back and forth at the same time. You are never going to be sending multiple megabytes of data at a single instant over your internet connection for some video game. It's little tiny packets of data. If nothing else, maybe, our clients, Charlie's client, Maddie's client, is just updating the server and saying, this is where this person is right now. And then as you move through the world, because you're running around in real time, as you're running around, your location in the world changes, and you have to notify everybody else that your location has changed. That way, their local client updates the player that used to be there, now that player's here. That makes sense? But that's going to be happening often. Lots and lots and lots of updates. So it's not the amount of a single send, it's the bulk of network activity that has to happen. And that's why latency is far more important for real-time applications like video games than total bandwidth. Bandwidth is much more important for like Netflix, video streaming stuff, especially if you have more than one person in the same house trying to do that type of stuff at the same time. All right, but when we synchronize this function, we are immediately adding overhead to this function, which will slow down the processing of our code, perhaps not noticeably, but you certainly don't want to just randomly throw synchronized in front of every single function just because it's like better to be safe than sorry. You want to do it for a reason. Make sense? All right, so synchronize, kind of new tool for us. Somebody try to remind me next time for me to get it into our slides because this guy is read-only at the current moment. So that's not going to happen. All right, so that's for adding or removing a player from a room. We're going to have something very, very, very similar to that for adding or removing a NPC, right? So we'll go ahead and we'll do a synchronized. We actually could probably steal almost all this. Let me just steal this. And I'll put a little comment above here. We'll call this player management. And then down here, we'll do this as NPC management. We'll paste this. And this is going to be NPCs perform action. If the action is to add an NPC, we'll say NPC temp is equal to the NPC version of whatever is at bucket 0. Then we'll say this dot NPCs add temp. And an NPC is likely going to also have to know what their current room is. That might be an important thing, right? Remember, NPCs, non-player characters, these are kind of like our monsters that are going around the area. They probably need to know what room they're currently in as well. or at least that might be a plausible thing they might need to know about. So we'll go back to our NPC here, and we'll go ahead and we're going to give them a private string name, and we'll give them a private room, current room, create their constructor, public NPC. All right, so we'll set the name, zero out the current room, set up our getters for name, and our getter and setter for current room. All right, so there's our current iteration of NPC. Go back to room here. So we'll set that NPC's current room to the room they were just added to. Similarly, if the action is add or remove NPC, we will extract the NPC from our parameters, and we will remove from NPCs that guy. And if it was a successful remove, then we'll set the current room for that NPC equal to null. And then for add NPC, this guy will take an NPC n, and we'll call NPCs perform action. We're going to be performing the add NPC action. Similar, remove NPC. Take an NPC, and we'll call it n here. One of the real reasons to change the variable name just to make it, kind of match what we're trying to do. Also, we'll then highlight in here where we need to make our modifications. So sometimes introducing an error on purpose then shows you the places you need to change it. All right, so I'll do that. And then make sure that we're calling the correct perform action. This is NPCs, perform action, and we're going to be removing an NPC. And there's our params. All right, so that's add and remove NPC. Okay. Lastly, and we can go ahead and do this, take this locked thing out. Went down a path there, ended up not being a good path. All right, so lastly, we need to be able to add exits. Now, when we're building out our dungeon, so we have to consider the order. If we're like playing with Legos here, right? So I'm creating some objects. So I'm going to have my dungeon or whatever. So now I've decided, and if we're doing the computer science department here, just these couple of rooms. So we have S120. I'm going to create a room called S120, and we'll call this S120 classroom. That's its description. So when we create that room, we'll be creating it with that information. S120, and well, actually, let's just do it. So out here in main activity, I'm just going to give ourselves a function, private void build dungeon or something like that. And for right now, we're going to create a room called S120, and this is going to be a new room. Name of the room is S120. Description is S120 classroom. Similarly, we'll have a room, what do you want to call that? CS hallway. It's going to be a new room. Name CS hallway. And description is the CS hallway. Okay, we like to be extremely detailed. All right, so I have two physically different rooms now. Okay, now last time we were making a decision thinking about how we're going to implement our exits, right? Are we going to have one exit that is shared between both rooms? So this room has a pointer to this exit. This room has a pointer to this exit. And depending on when a player takes an exit, depending on which room they're currently in, it would take the other one. I think that's the one we decided on, as opposed to the CS Hall having its half of the exit and S120 having the other half of the exit. This one always leads to CS Hall. This one always leads to S120, but these are physically separate exits. So in this model, we actually think of this door as being two separate entities, a front and a back half of the door. So if this is the front half leads to the hallway. The back half leads to S120. So that's one way we could implement this. I think we did decide on this way, did we not? Okay, if we didn't, then it's your fault, Charlie. If we go down a bad path here and this becomes difficult, this is on you. Well, in my mind right now, we've already dealt with I'm old and senile. I don't know how fine this is. We should be planning this stuff out in Keynote. We can't use this read-only program on the computer. That's what makes programming fun, right? Sometimes you just take the leap. It's what also makes software engineering boring. But it's so important, especially in large projects when you're working with multiple people. It's good to have all that stuff documented. So like, if Charlie's working on one part of the project and I'm working on another part of the project, we can reference the objects that are involved. And I don't just make some assumption about this object. Or let's say I'm the one creating an object. I might say, oh, well, it has these 30 other things that we never discussed. So now it has these 30 obviously awesome things, right? Charlie doesn't know about it. He's using that same object and he's doing it like this really, hard way because he didn't have my power tool objects. And then I laugh at him. It's called job security. That's an old joke in computer programming. As in class, we're kind of teaching you to, write easy to read code, somewhat self-documenting code, name your variable, something appropriate, that kind of stuff. But from a job security perspective, if you make your code such that you are the only human being that can read it, well, they can't really fire you, probably, right? What's up? Oh, that's true, but it's kind of extra applicable to software or any kind of writing or something like that. If you're like a research scientist and you've encrypted all your stuff, yeah. So I mean, at that point, you have a direct tool towards that. If you're, if like you're a janitor or something like that, there's not a whole lot you can do to like make yourself irreplaceable, right? I guess maybe if you have like a secret cleaning solution or something like that, and you won't share the recipe. Would that be kind of concerning if there was like a janitor you found out who had like a secret like recipe, like they had a lab somewhere? That would be concerning, I think. Well, that's his day job. He's an evil supervillain the rest of the time. He'll be one of our NPCs. Dr. Destruction, the janitor. Oh, no, it's got to be a Splitterator. Splitterator, the janitor. Charlie, write that down. We don't want to forget that. Splitterator, the janitor. He's going to be our first boss. All right, so we're going to do this model here where we have our a single exit that exists between two rooms. So the premise would be out here, we would create an exit. So our exit, we build it, passing it the two rooms that it, links. And then we will have, we'll set those couple of variables. So we'll go ahead and we'll call this maybe, we probably want to, now this comes down to naming convention stuff. So inside of here, we might say exit, and I'm going to call it S120 CS hallway. Maybe something like that. that kind of gives us the premise that these two are linked together. This is going to be a new exit with S120 and CS hallway as the two rooms that exit presumably links. All right. Now what we would do is we would add this exit to S120 and to CS hallway. So we need to go back into our room guy here, and we're going to create a thing for. Now, we can create a thing for exit management if we wanted to. We might say, is there ever going to be the need to remove an exit? And that's something that we really do want to think about from a game perspective. Because I can kind of see maybe there being like a spell, and a spell like, removes a certain exit in a room. Or maybe our wood chipper can grind up exits. But if we're assuming that's not going to be the case, the only thing we would be doing to a room is adding exits to the room. That's the only thing we would be doing that would be possibly modifying the exits hash table. Okay? So we'll make that guy synchronized. All right, and we'll go ahead and this is going to be public. We'll call this guy add exit, and it's going to have a string direction and then an exit E. And then what we'll go ahead and do is we're going to modify our dictionary. So we'll say this dot exits dot put. So we're going to put a new element into our dictionary. So we're putting at bucket direction the exit E. That makes sense? So what I might do out here in main activity then is I would go ahead and I would say S120 dot add exit, and we're going to add this exit to the north, and the exit is going to be the S120 CS hallway bridge thing. And then from CS hallway, we will be adding an exit to the south, and it'll be that same exit. So from S120's perspective, internally in their hash table, their dictionary of exits, they will have a bucket north that will lead to the CS hallway. Well, that will ultimately have this exit associated with it. From a CS hallway's perspective, they will have a bucket south in their dictionary that will give them the exit that leads back to this room. That make sense? So what we're going to go ahead and do here, just for testing purposes, I'm going to go ahead and I'm going to say, this is going to be another public function, public Boolean take exit. And this guy is going to take in a string direction. All right. And then we want to attempt to take the exit in that direction. So we're going to say if this dot exits dot, let's see, do we have a, think this will give me the exit. So I'm going to say get me whatever's at direction. And we're going to print that out for right now, just so we have our setup for our homework. And then for now, I'll just return true. All right, so if we attempt to take that exit, we're going to try to get that exit. We should get an exit object printed out. So then back here in main activity, we'll go ahead and try to do a couple of exits. We'll do s120.takeExit north. Then we'll say s120.takeExit, we'll just say west, which should be, that should fail, right? That should give us a null. And then we'll say CS hallway.takeExit south, like that. All right, so now when we run this, this should look up those, hold on, I need to, I'll go ahead and get this launching. And we'll say this dot build dungeon. All right, so I'll let this finish launching. I know we're out of time. So for our homework, what we want to do is, test this take exit thing, and then if an exit was able to be taken, modify our exit code. So we can go ahead and say public void take exit. This will take a player P as a parameter. Make the player move to the room they are not currently in. So when a player takes an exit, they will move to a room that is the other room. So if they're currently in room 1, they would move to room 2. If they're currently in room 2, they would move to room 1. How do we know what room a player is in? P.getCurrentRoom. A player can advertise what their current room is. Make sense? And I'll put this up on GitHub. One thing we might want to do here just for the last little piece, player P is equal to new player, pass in Mike. And then let's go ahead and let's throw Mike into s120.addPlayer P. So that way Mike will initially be in S120. If he takes the exit to the north, he'll end up in the hallway. If he's in the hallway and he takes the exit to the south, he'll end up back in this room. Make sense? So write that piece. Shouldn't be too huge, but it'll force you to kind of get used to using our system here. Today, faculty, student, staff, Bible study, God and Grub. Go to the cafeteria, sign in, get your free lunch, take your tray down to the terrace room. And I will see everybody on Thursday. If you have not already done so, make sure you contact Professor Josh Locklear. Sign up for the hackathon. Let him know if you want to do VR or mobile apps. Do that as soon as possible because we're going to probably be putting together teams this week. The who? Oh, there will be Bible homework today. I forgot to put it up before Easter. Yeah.
Hey, I just